Hi guys, welcome back to another video. So today we're going to do a acid-base reaction type question on the channel. So the question is asking us to calculate the pH of the solution that results from each mixture. So this mixture, it's 50 milliliters of 0.15 mole per liter acid, and then we have a 75 milliliter of 0.13 mole per liter of our conjugate base. So I just wrote down the approximate reaction right here. So this is our approximate reaction, which will be very important. And then a couple things we already know is we know our Ka of our acid, which is 1.8 times 10 to the negative 4. And then what's really important here is that our pH is equal to our pKa plus the log of our conjugate base divided by, the log of the concentration of our conjugate base divided by the concentration of our acid. So the first thing that we want to do, or that we're going to do, we're going to start with our pKa, finding that. So to find our pKa, it's equal to the negative log of our Ka. So it's pretty easy to find in this circumstance. So it's going to be the negative log of our 1.8 times 10 negative 4. So it is equal to 3.745. So not too bad there. But it's going to be this part that's going to be a little tricky for us. So the first thing we'll do is we'll calculate it for our acid. So our acid is here. Oh, here, I'm gonna use a better color. Our acid is here. And we're gonna focus on calculating its concentration. So first we're gonna calculate the number of moles. So our number of moles of our acid is going to be equal to 0.15 molarity times 0.05 liters, since it was 50 milliliters. And this is going to give us 7.5 times 10 to the power negative 3 moles. And then, but we want its concentration. So we'll have to divide it by the amount of liquid now. So our new amount of liquid is going to be the 75 milliliters plus our 50 milliliters, which is going to give 0.125 liters. I just translated it into liters because it'll be a lot easier to find the concentration. So our concentration of the acid is going to be 7.5 times 10 negative 3 moles divided by 0.125 liters, and it's going to equal 6.0 times 10 to the negative 2. So we have that in check, but now we need the concentration. So this is our acid. Just want to make sure. Concentration of our conjugate base. So HCOO minus. For our conjugate base here, we can mark it here too, just to clarify. Okay, here we go. So if we start to calculate this, we'll find that our number of moles is equal to, now it's going to be 0.075 liters times 0.13 molarity, like in our question. And if we calculate that real quick, we have 9.75 times 10 negative 3. And this is going to be our moles. And then 9.75 times 10 negative 3 divided by our here, CHOO minus concentration is equal to, divided our 0.125 liters of liquid again, which is going to give us 7.8 times 10 negative 2. Sorry, I don't know why I said conjugate base, just our base. There we go. So we have concentration of our acid, concentration of our base. Sorry, it's almost illegible. And then we have our pKa, so now we can put it all together to find our pH. So I'll just start here. I'll just start down here with our values. So pH is equal to the pKa plus log of the concentration of our base on the concentration of our acid here. So that's going to be equal to 3.745, which we calculated over here, plus the log of the concentration of our base. The concentration of our base is right here, 7.18 times 10 negative 2, divided by the concentration of our acid over here, 6.0 times 10 negative 2. And then if we throw this all in the calculator, we're going to get 7.745 plus 0.114, which is equal to approximately 3.86 as our pH. So it's pretty acidic pKh. So it must not be going all the way over here. But yeah, that's how you'd solve one of these pH questions from a acid-base reaction over here. Okay, thank you for listening or watching, and hope you have a great day. Don't forget to like, subscribe, and share, and comment if you have any questions. Thank you.